Hi, everybody. Tommy Clayton here, an OpenSciEd teacher and writer. Excited to dig into lesson 6 from unit 8.1, which is the contact forces unit. You know, the first time I taught this lesson, I handed out the assessment that happens in this lesson, and students were like, "What? We didn't talk about soccer. We don't know anything about soccer." And there was this really big, high level of anxiety in the room. So I learned a few things about this lesson, and I've since done it differently. So I'm excited to share some of that with you, so you don't fall into a similar scenario that I fell into. So in this video, we're going to look at how we got here. We're going to take a look at this lesson at a glance, dig into some of the key moments, and then talk about some tips and tricks for this lesson. So let's dig in. All right, let's remind ourselves of how we got here. So we are coming off of lesson 5. And lesson 5 was a pretty big lesson where we figured out some big science ideas. Particularly, we figured out that in a collision, however hard something pushes on something, the other thing pushes back equally, right? So those peak forces in a collision are equal to one another. We also figured out that there's this like general relationship that like more mass and more speed, right? Either one of those results in a higher peak force in a collision. So we don't necessarily know like specifics of that relationships yet, but we know that like if things are going faster, there's going to be higher peak forces. So in this lesson, we are at a point where we really have some cool understanding of things happening. Like we figured out so much. And so we're wondering, like, can we apply these ideas to a different scenario, right? So can we look at something where objects are colliding and apply what we figured out to that? So let's take a look at this lesson at a glance. So this is a putting the pieces together lesson. This is a little bit different than what we've been doing in our investigation lesson. So if this is the first time you're doing this, it might feel a little bit different, especially for the kids, because it takes on a different format from what we've previously been doing. This lesson is one day. It takes about 20 minutes to get set up for it. There's no hands-on investigation. Students do not need devices, and there are no additional related videos. All right, so there's only 4 parts to this lesson. We navigate in, we revisit our driving question board, and then we spend a majority of our time digging into that lesson 6 assessment. And then we're going to navigate out by actually using questions on the assessment. So we'll dig into that in a few moments. So in this lesson, we don't necessarily figure out like new information. We do figure out that we made a lot of progress on our driving question board. But pretty much we're just putting the pieces together, hence the name, and taking all of the things we figured out about peak forces and damage and kinetic energy, and we're applying that to the game of soccer. So let's take a look at some key moments in this lesson. So in part 1, we come together and we essentially list all the big science ideas we have figured out so far, and we make this anchor chart called What We've Discovered. We co-developed this list, and here we're looking to just draw out what we figured out about forces, about energy, about collisions. And so you don't need to spend a whole lot of time here. You're going to have another chance in the next part of the lesson. So if you get to a point where kids are sort of done sharing ideas, and maybe there's still a few ideas that you want on there, that's okay, because when we get into the next part, you'll have another chance to add to this chart. So in part 2, we're going to revisit the driving question board. We're going to see what type of progress we've made. So here's where you're going to want to take a picture of your driving question board, or just type up the questions themselves so that kids have access to the question board. They want to be able to see the questions. They're going to pick 3 questions that they feel like we've made progress on, that we've answered, or we've almost answered. They're going to share out the answers to those. In particular, they're going to dig into one question that they can answer. And so here's a moment where you can return to that What We Discovered poster. Maybe a student shares out an answer to a question, and you know that we don't have that on our poster. You're like, oh, cool. That sounds like something we should add to our poster. The poster is also useful here because if a student shares out maybe an answer that's goes against what we've put on the poster, there's a moment where we can call back to the poster and be like, okay, well, on our poster, we said this about forces, but it sounds like you're saying this, right? So let's make sure that those two align. And so in this moment, students are going to be sharing out these big ideas about forces and energy and collisions. So here's an opportunity to really formally assess what is happening before you actually dig into this summative assessment. Okay, so part 3, this is where we're going to spend most of our time in this lesson, is the assessment. It's about 5 pages long, and students are going to start by drawing a free body diagram. Then they're going to answer some questions about how forces compare in particular collisions. They're going to think about the effects of mass and speed on peak forces. And then there are 2 questions at the end of this that are actually for navigation purposes. So here you're not looking for necessarily a right or a wrong answer per se. It's really going to help us navigate into our next lesson set. Okay, so lesson 7 is going to start a new lesson set. So we figured out a lot about like collisions and forces and a little bit about energy. The next lesson set is going to be a lot more about energy. And so we're going to, in lesson 7, really start to figure out like what happens when you change the mass of objects and what happens when you change the speed of objects. Like, does changing one of those have more of an effect on like the amount of energy or the amount of damage, depending on what we're looking at? All right, so here's some tips and tricks for this lesson. The first thing is that I learned is before we even hand out this assessment, we want to share with the kids and be very intentional about what we're about to do, right? We're about to transfer knowledge to a new phenomena. So I learned that you can't just like hand this thing out and sit at your desk and expect the kids to like tackle this thing. It's very different from what they're used to when we think about giving them an assessment. So the first thing I recommend is name what we're doing, right? Scientists take these science ideas and they apply them to different phenomena. And that's what we're going to do. We're going to take what we've figured out about collisions using our cars and thinking about phones and all that stuff. And we're going to apply it to the game of soccer, right? And it's okay if you've never played soccer, right? It's okay if you've never even seen the game, because what we're going to focus on is the collisions in soccer. And so sharing that with students, I think I learned helps get them ready for what we're about to do and makes them feel like, okay, cool, I can do this. I know some stuff about collisions, okay? I recommend reading the first page together. Ask students to annotate it. Maybe they read it on their own, quietly annotate it, and then come together as a whole group to share out like what's happening in that opening part. Talks about concussions and heading the ball and some things like that. You may want to read it out loud with students together, or maybe they read it in small groups, right? But I think the first time you want to do this, we're helping kids understand how to extract that information and really set up what this task is about, right? And this is kind of a new thing for students. And so you're going to want to spend a little bit of time here reading that first part of the assessment. You may want to also preview the rest of the assessment with them, right? Read each question out, have a little discussion about what it's the question itself is getting at. And another strategy that I really like is providing one page at a time, right? So here's the first page of the assessment. We're going to all look at this. We're going to read it. And when you're ready, you can come up and see me for page 2, right? Sometimes handing this amount of pages to students can really be sort of overwhelming for them. Okay. I think it's great if you can leave the model up from lesson 5. I think that's really helpful. It has the free body diagrams. And if you did the exit ticket at the end of 5 and ask them to actually draw a free body diagram, you can have them refer back to those for that first question. I think it's important to be explicit with the kids, because a lot of times they can just draw like a picture of somebody heading a ball, but you may want to draw out that we're really looking for you to show the forces here. And like we just learned about a free body diagram in the previous lesson. So it's a little bit new. And so you may want to like draw that out so that students know exactly what you're looking for in this case. So then you can assess where they're at with drawing free body diagrams. I would draw students' attention to questions 6 and 7. The language in those says, do you think? Right? So telling kids here that we are not looking for necessarily like a right or wrong. This is about wanting to know what you actually think about this, right? And so the question is asking students to think about whether mass or speed has more of an effect on kinetic energy. and then they propose an idea for an investigation. And so those are not actually like part of the scoring in this. You're looking for complete answers here, but there's not necessarily a right or wrong. We're going to use these to like navigate into the next lesson. There is a sample responses document that you can use to develop your scoring ideas. So there's nothing on there about like actual points, right? That's up to you because that's going to be district specific, but it does indicate what an answer that is secure looks like. And then you can kind of decide there how you're going to score the rubric, but you do have something to refer to as far as looking at like a complete answer. Okay, there are two words we encounter during the assessment, and the first one is concussion, and the other one is where we dig into learning more about the brain. The word neuron is in there, but they've been exposed to that in previous uh, units, I think. And then axon is the other one where they look at this diagram and find out more about the brain. So they're going to encounter both of those on the assessment. And again, if you're previewing the questions, maybe you take that moment to talk through those words a little more with students to make sure that they really understand those words as they move into the assessment. Okay, as we talked about at the beginning of the lesson, we have the What We've Discovered poster. We are going to refer back to this in a future lesson. So in lesson 10, we'll have another assessment coming up, and we're going to add some big ideas to this and use this again. So hang on to this poster. It's really something great to have in the classroom if you've got the space or a way to refer back to this as we move into the next lessons in our lesson set. Okay, and that's going to do it for lesson 6. I wish you good luck with this assessment. It is really, really cool to see the kids apply what they figured out to a whole new scenario. And kids often do want to look at sports collisions. It's usually something they identify on their ideas for investigation. So this is kind of a nice moment for them to think about like how what they're learning in science class connects to possibly some of the sports that they play. Come back and join us for lesson 7, and you're going to see where we go with figuring out more about energy. Thanks, and we'll see you soon.